There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention.
fire.
There's going to be a short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, hello everybody. I'm Chemical Charlie, and
I'm Pie Guy Pepin.
And we have here the ingredients for an electrochemical cell. This is magnesium sulfate. So there are magnesium ions in that solution, Mg2+. And this is copper sulfate, CuSO4. So we have copper ions. And Pie Guy Pepin is going to show you that if you take copper metal and put it in magnesium ions, nothing happens. Show him, Pie Guy.
Yeah, nothing happens. There's nothing.
Okay?
However, if you put magnesium...
No, just dunk it in, but keep it in your hand. And 10, 9,
You can
8,
hear it, actually.
7, 6, 5, 4, 3, 2, 1. Now take it out. Okay? Now show the audience. You can see that it got kind of a blackish color on it. So what happened to the magnesium metal? The magnesium metal lost 2 electrons. Each metal ion lost 2 electrons, and they went on to copper ions and caused the copper ions to get reduced to copper metal. The black stuff on there is actually copper metal. Eventually it becomes kind of shiny copper, but it takes a little while. So there's a tendency for magnesium to lose electrons and copper ions to gain electrons, and we're going to produce an electrochemical cell. Magnesium here, copper metal here.
A wire. We're going to hook up a wire from the copper to the magnesium.
And of course, we see nothing happening, all right?
Oh,
and the reason is we don't have a salt bridge, all right? So let's create a salt bridge. So I'm going to put one side in here and one side in here. And we may not have this lined up right. You have to have the right polarity, so let's switch it. Okay, you can see it's glowing. Beautiful, yeah, that's nice. All right, now if I remove the leads, of course it goes out. In this compartment, I have magnesium metal, Mg, without a charge. The Mg atom loses 2 electrons. The electrons go through the wire, and they cause the LED light to go on. And then the electrons go over to the copper compartment. They go onto the copper metal and into the solution, and they cause a copper ion, Cu2+, to get reduced to copper metal. Because copper ions are coming out of solution here, the salt bridge maintains neutrality by having positive ions. This is a sodium chloride salt bridge, but positive sodium ions replace the copper that got reduced. And because magnesium ions went into solution here, the chloride ions go into the compartment to neutralize the charge so that you're getting electrical neutrality. Electrochemical cell will continue to light the bulb as long as there are chemicals available, all right? So it's an example of an electrochemical cell that produces electricity that's strong enough to cause the bulb to light up. Now, reduction takes place at the anode. So reduction is taking place over here. The copper is getting reduced. That's the positive electrode. And oxidation takes place here, and that's the negative electrode. Chemical Charlie.
Pie Guy Pepin.
And we'll see you next